Let's do a general overview of factoring from a little bit you may have learned in grade 9 and mostly in grade 10. So factoring, first of all, the definition is to write an expression, which expression you can just think of as an equation, as a product. So a product is when terms are multiplied by each other. So this bracket, in between this bracket, there's nothing, no adding sign, subtracting sign. Then it's implied that you multiply. It's the only time you don't have to write a sign. If you're adding, subtracting, or dividing, you need to show a sign, but if you don't see any sign, then it means that you're multiplying. So if I had this expression, 2x cubed plus 3x squared minus 11x minus 6, this expression would be in standard form. And if it was to equal x minus 2 in brackets multiplied by x plus 3 multiplied by the binomial 2x plus 1, this would be in factored form. So factored form has brackets. If you want to get something into factored form, it means that your final answer would have brackets. If you want to have something in standard form, it means that your final answer wouldn't have any brackets. So what we want to do first, and I'll provide a factoring tree to you. If we look here at the factoring tree, the first thing you do is common factor first. It doesn't even matter if it has 2 terms, 3 terms, 4 terms, etc. The first thing you do is common factor first. So if we go back, what is common factoring? So we look for the greatest common factor, which a short form, we call it GCF. Now each letter here is important. The G for greatest is important, common, and factor of each term in the expression. So let's say factor the following. Let's say we had 4x minus 12. So before I look if there's 2 terms, before I look if it's difference of squares, always the first thing you want to do is see if you can common factor first. Meaning, is there something common between the 4x and the 12? And if I look at the variables, there's an x here and there's no variable here. So that's not common to both terms, so I can't pull out a variable. Now, number-wise, what's common to both the 4 and the 12? And for example, a 2 is common, right? If I was to skip count by 2's, or take 4 divided by 2, I would get a whole number. And 12, or negative 12 divided by 2, and I would get a whole number. We don't want decimals. If I get whole numbers, that means that I can factor that number out. But the G part here, the greatest common factor, is important. So I want to look and see if there's a number greater than 2 that I can take out. And there is. The greatest common factor here would be 4. And again, not an x, because we talked about that already, how the x isn't common here with the 12. So if I take a common factor out of 4, in order to find out what's left in the bracket, you could take the original term, for example, the 4x, and divide by your GCF, which is 4. And the answer to that, so which would just be x, would go in the first term. The second original term was negative 12, for example. Divide by my GCF. So you can include the sign, because then whatever the answer is, negative 3, you include that sign, negative 3, as part of the second term. And that's as far as I would go. I'd have 4 multiplied by x minus 3. Now, the one good thing about factoring is you can double check all of your answers here. Because if I was to go back and do the distributive property, now this isn't part of my answer's finished, right? But if I was to go back and do distributive property, 4 times x, 4 times negative 3, I would get 4x minus 12, and I would get right back to the original question, which tells me that I've done it properly. Okay, let's look at the next one. Binomial factoring. meaning if I have just two terms, there's difference of squares factoring. So here's an example, x squared minus 25. So there's a negative sign there. That's what the difference means, right? Difference of squares, meaning that it has to have a negative sign in between them to be difference of squares. And each original term has to be a perfect square. Excuse me, or another way that I say it is the term square rootable, meaning can I square root x squared and I get a whole number, not a fraction or anything. So the square root of x squared, again, the square root and the squared cancel each other out, and I'd be left with an x. And the square root of 25, don't worry about the negative sign here, because it's always going to be a negative sign for difference of squares. So you're just looking at the numbers, is 5. So 25 is a square rootable term. It's a perfect square. There is a number times itself that gets me back to that original term. So once I figure out that it is a difference of squares, how do I write out my answer? Now, one way to start writing it out, if you realize this, is you could start writing it out as x squared minus 5 squared, if that helps you, so that it looks like this here. So that this here looks like this example here, a squared minus b squared. So then in this case, a would be x squared and b would be 5 squared. And then you just follow these steps. So what I would do is, once I'm here and I have my x and my 5, I make 2 brackets where I'm going to write my answer. And the answer to the first term that you square rooted, x, would go in the first spot of both brackets. The answer to the second term square rooted goes into the second spot of both brackets. And just that one is a minus and one is a plus. So I'm going to put plus first and then minus, just because in the original example we had a negative sign and then a positive sign, just showing that it can go either way. It doesn't matter if the negative sign is first or second. So that's difference of squares if there's a negative sign. What if there's a positive sign, meaning sum of squares? So if I had the same question here, if I had x squared, but plus 25 instead of minus 25, it's unfactorable. So I cannot factor this. It's only if it's a difference of squares. Okay. So let's move on to difference of cubes factoring. If you need to pause this, and if you're not caught up, and write this down, because I'm just going to clear the screen to move up and then come back. Difference of cubes factoring, meaning the same thing as difference of squares factoring, but that each term here, I have to be able to take the cubed root of it. So for example, x cubed minus 27. And hopefully after a while, you'll get to know some numbers that you can take the cube root of. But if you're wondering, if you see an x cubed here and you're not sure about this number, right, it should be, and you see that it's 2 terms and that you have a negative sign, it's kind of giving you an alert here that it may be a difference of cubes, right? So then you can just see, can I take the cubed root of x? Yes, that would just be x. Can I take the cubed root, right, of 27? Which you could use your calculator, or what number multiplied by itself again would give me 27, and that would be 3, right? Because 3 times 3 is 9. 9 times another 3 is 27. So then both of these can be cubed rooted. Both of these are cubes. So then the way that I would answer this, again, I could say here that my a value is x, and my b value here is 3, and I could copy this out. So what I would do is a minus b. So just x minus 3, and the first binomial here has to have the negative sign. That is always the way that it works, would be x minus 3. And then beside that, I would write a squared, meaning x squared. The last term is b squared, meaning 3 squared. Well, I don't have to write 3 squared. I can just go ahead and put 9, 3 times 3. And they're all positive signs here, right? And then in the middle is a times b, so 3x. So that's x minus 3 as the binomial. And then the trinomial is x squared plus 3x plus 9. And again, also, if it helps you before you start, you can rewrite this as x cubed minus 3 cubed, if that helps you. And then this trinomial here is always going to be unfactorable. So once we get into what simple trinomial factoring is, just going ahead looking for two numbers that multiply to 9 and add to 3, you won't find that. They will always be unfactorable here. Now, sum of cubes factoring, right? Sum of squares doesn't work, but sum of cubes factoring is factorable. So it would look like, again, a number that's a cube with a positive sign and another term that's cubed. So for example here, let's use the same example, x cubed plus 27. So if you see that the first term is cubed and it looks like the second term might be a term that I can cube or take the cube root of to see if it works, then there is a sum of cubes factoring that I can do. So same thing as before. I can write this out as x cubed plus 3 cubed, right? With a positive sign now. So a is going to be equal to x, same as before, and b is going to be equal to 3, and then just follow the setup here. So I have a plus b. So now I have x plus 3 as the binomial, and in the trinomial, I have a squared, so x squared, but don't forget this has to be a minus sign now. The two terms multiplied by each other, 3x, and then plus b squared, 3 squared is 9. So it always goes in this order where you have x plus 3, and then you have the negative sign as the first sign in the trinomial, x squared minus 3x plus 9. And same thing as before, actually, this trinomial in this case as well is unfactorable. So again, right next here is simple trinomial factoring. But if I was to look for two numbers that multiply to 9 and add to give me -3, it doesn't work. And that's the way it'll always be with difference in sum of cubes. The last trinomial term will be unfactorable. Okay, so simple. Different types of trinomial factoring, meaning if it has 3 terms. So one way would be simple trinomial factoring, and simple trinomial factoring simply means that it always is that a is equal to 1. So this first term here always is a 1. So you'll just see it as x squared plus a number x plus a number, right? Use the product sum method, some people call it. Find two numbers that multiply to c, that multiply to the last number, and find two numbers whose sum, whose adds to the b value, to the middle term. But I would just suggest one way to memorize this, let's say, is because when we get into complex trinomial factoring, is to always just get in the habit of when you're looking at two numbers that multiply to the last term, just get used to doing the last term multiplied by the first term anyways. That way it's the same when we get to the other factoring style. So find two numbers that multiply to the last times the first number term and add to the middle. So for example here, let me just move this over as well. if we have a look here, this x squared minus 3x minus 18, we can see right away that the a value here is 1. So that means that it's simple trinomial factoring. So I'm looking for two numbers that multiply. Off to the side here, I just write that multiply 2 and add the signs in, negative 18, which would be negative 18 times 1, right? And adds to negative 3. So right off the bat, if I'm looking for two numbers that multiply to a negative, I have to know that one of the numbers is going to be positive and one of the numbers is going to be negative. The best way to figure this out, if it doesn't just come to you automatically what the two numbers are, sometimes that will happen, is just to make a list of everything that multiplies to 18, starting with 1, just so you don't accidentally miss a set of numbers that might actually be the answer. So 1 multiplied by 18 is 18, 2, right, multiplied by 9, 3 multiplied by 6, 12, 18 is 4 multiplied by anything, 5 times anything, 18, no, 6. And what happens is if you're back to 6 and you say, well, yeah, 6 times 3, but if it's already listed there, you're basically going backwards. Once you go backwards, you know that your list is done. It's been exhausted. So it's either 1 and 18 is your answer, 2 and 9, or 3 and 6. And that's when you look at the sum number here. I want to add to negative 3. So then I look at what has a difference of 3, which 3 and 6 do. So how do I get negative 3? If the negative was on the 6, the larger number, negative 6 plus 3 would give me negative 3, and is negative 6 times 3, negative 18. So then those are my numbers. And once I have my numbers, I just simply put those numbers into brackets. So I just simply write again the product of two binomials. And x squared is in front, meaning I'm going to have x in the beginning of both brackets. And then I write the one answer, positive 3 in one bracket, and one answer of negative 6 in the other bracket. And again, it could have been negative 6, x minus 6 first, and x plus 3 second. That doesn't matter at all. It can be written either way. Can be written either way. So now let's review complex trinomial factoring. Complex is the same sort of understanding. The only difference is that the a value here is not equal to 1, meaning that you're going to have a number that's in front, like a 2 or a 3 or a 4. So for example here, we have 12x squared plus 11x minus 5. We're going to go about it the same way. We're going to look for two numbers that multiply to negative 5 times 12, the first times the last term, and add to the middle. So let's write that down. I'm looking for two numbers that multiply to, again, negative 5 and 12 is negative 60, and that add to positive 11. So I know that the numbers, again, have to be one positive and one negative. So let's start writing everything that multiplies to 60. So 1 times 60, 2 times 30, 3 multiplied by anything is 60. And if you weren't sure, you could also just take 60 divided by 3. And if you get a whole number on your calculator as an answer, that means it works. You don't want any decimals. So 3 times 20. Does 4 work? If I take 60 divided by 4, 4 times what is 60? 4 times 15. And 5 would work as well. But also when I take a look at the numbers, I'm looking if one has to be positive and one has to be negative. This has a difference of 11. So I'm going to stop here and take a look. If 11 is the positive, if I put the positive on the bigger number and the negative with the 4, then 15 minus 4 gives me 11, and positive 15 multiplied by negative 4 gives me the negative 60. So then that would be my answer. So the only difference though with complex factoring is that you need to, when you have your answer, you need to divide by the a value because a is not 1. So over here I have negative 4, just because I'm running out of room on the right side here. So negative 4 divided by, what is my a value here? 12. and positive 15 divided by my a value of 12. And then I want to get it in lowest terms before I can put my answer in brackets. So the lowest term there would be negative, this divides by 4, divide by 4, I get negative 1/3. This divides by 3 and divides by 3, and I end up with 5/4. And that's as low as I can go, that's lowest terms. So now when I go to put my answer here as two binomials, the denominator of my lowest term fraction is actually the beginning term. So here this 3 is 3x. This 4 is actually 4x. And the numerator is actually the second term. Usually we put the negative sign up with the numerator, right? So then the second term would be -1, and here positive 5. So my answer is 3x minus 1 and 4x plus 5. And again, those could be switched, and it could be 4x plus 5 first and 3x minus 1 second. And if I were to do FOIL and multiply those out, I would get back to the beginning, and that's a way I could double check if my answer is correct. Okay, what about perfect square factoring? Perfect square factoring would have a general look like a squared, and it can be a plus 2ab plus b squared, or it could be a minus sign. A squared minus 2ab plus b squared. But notice how this term, the sign in front of the third term is always positive though. And then your answer would be either a minus b and a minus b if that was a negative, or a plus b multiplied by a plus b if it was all positive signs. So if we look at this question here, we have 9x squared minus 42x plus 49. Right away, we can see it's not a binomial, so I'm not looking at difference of squares or difference of cubes if I'm going in order of the note so far. It's a trinomial. It's not simple because a is not 1, it's complex. So could I do it the way that I just did and look for two numbers that multiply to 49 times 9 and add to negative 42? Yes, 100% you can, but look at how big those numbers are, right? You'd be looking at a number of 49 times 9 and adding to negative 42, which in some cases you might have to do. But then the first thing you want to look at when you have numbers this large is there a simpler way to answer this? So a trinomial could also be perfect square factoring, which means is the first term a perfect square? And is the last term a perfect square? So what I'm looking at first is, can I square root 9x squared? So the square root of 9 is 3, square root of x squared is x. Can I square root 49? And again, don't worry about the signs right now. We'll worry about the signs if this works when we're going to do our answer. Okay, so both terms are perfect squares. Both terms are square rootable. But then I have to double check the middle term. So what we want to do is, we always want to look at our answers. So I want to look at 7 multiplied by 3. So I want to take the two answers and multiply them together, and I get 21. And the term in the middle of the original expression here will be double that. So is the middle term double that? So if I times by 2, I get 42, and that works. Now, if that works, then 100%. It's a perfect square trinomial. So you have to double check that first. Get your answer, multiply it together, and is it double that? So I'm ready to write out my answer. So what I do is I take my answer to the square root of 9x squared, which is 3x. That goes in the first term of my binomial. I get my answer to square rooting the last term, which is 7. But I take the sign from the middle. So if it's negative here, it's negative. This is what we were talking about up here originally. And if it was positive all the way around, then I would write positive. And you can put squared. Now that would be the same thing as writing 3x minus 7 multiplied by 3x minus 7. But you can also just write it as 3x minus 7 squared.